Chapter 4.4 is going to introduce yet another tool to differentiate, or another shortcut. It's called the chain rule. What you want to do when you walk away from this video is be able to recognize what a composition function is. So we're going to review that, and then also not only recognize it, but then know how to derive it using the chain rule. So know the composition functions, be able to derive them using the chain rule. Alright, so we've had a lot of shortcuts so far, or not a lot, just a few to keep straight. So what we do have are these four that we started out with. We had the power rule, constant rule, scalar multiple rule, and the sum and difference rule. And then we added on to that something that dealt with the product, or the multiplication of functions, so the product rule. And then we also added the quotient rule, how to derive quotients. So this is a good warm-up. You can do all of these. The constant, scalar, power, sum and difference, product, and quotient are all listed out. You could go through deriving all of these 1 through 6 problems because we have the knowledge of these shortcuts. We would come across things like this, as complicated as it may look, and be able to say, hey, I can use the quotient rule on it. And then when you did the quotient rule, you would find that you would have to use some of these other rules within the quotient rule. If you got a problem like this, however, that's when you might start to have to make things up, because you would say, now wait a minute, what do I do with this grouping to the power of 3? Do I try to pull down that 3? What do I do with the grouping and the parentheses? So that's when you would start to make things up. That's when you're going to say, no, now, that's a composition function. So a composition function is recognized as a function within a function. Basically, if you have a grouping to some sort of power higher than a degree 2 is easy to FOIL out. But anything higher, complicated. If it's a fractional exponent, so in other words it's underneath a radical, that's also hard to deal with. So first of all, do not ever try to do that thing of distributing two terms being added or subtracted. Alright, so don't try to take this 3 and distribute it to each term. Composition functions also are defined as a function within a function. This is how we used to notate them and used to work with them last year. This g of x is what we would call the inner function. Inner function. Okay, and this f would be the outer function. Okay, so this is the outer function. So let me kind of just give you an understanding of what that would look like. So we had the same function, and what I'm going to identify is that g of x is this inner function that, alright, x is, something's being done with it, and then that whole thing, something's being done with that. So I'm going to call this initial inner function 3x to the 8th plus 2. I was simply saying you would take an x, bring it to the 8th, multiply it by 3, add 2 to it. So there that is. And my outer function, though, then, is not only am I going to do all of that, but I'm going to take all of that, and then I'm going to cube it. So I'm going to cube some sort of input. So now, if I did my FOG, or my f of g of x with that hollow dot notation, what I'm going to get is this, f of g of x. And g of x, we would first say, alright, that's what we're going to simplify first, is just identified as this. So we have f of, and then 3x to the 8th plus 2. So there is what g of x is equal to. Now f of x, we would say, is equal to x cubed, the input cubed. So don't forget, this is a lot like what you guys were working on when you had that x plus h and you're like, where do I put x plus h? How do I incorporate that in? Well, don't forget this notation is simply saying, identify your f function, and this is my input. So identify my f function. Well, here it is. I'm saying take an input and cube it. So here's my input, cube it. Right, so there we have it. Another notation that we use is the letter u, and we would say, well, u is equal to the 3x to the 8th plus the 2, and this is just once again saying that this is the inner function. We use u to notate inner function. Okay, and then we would say the f of u would be equal to u cubed. Okay, so we're just saying take your inner function and cube it. What is your inner function? Well, u is equal to 3x to the 8th plus 2. So that brings us to how to derive a composition function, and what we do is we use the chain rule. So I'm going to go ahead and notate the equation that we were just working with, 3x to the 8th plus 2 all to the third as this. Okay, so y equals this, and in order to derive it, what we're going to identify is, in English, is you're going to derive this outer function with respect to u, and then you're going to multiply by the derivative of u with respect to our x. So overall, to derive this equation with respect to this x value, in order to do that, you're going to have to go through deriving with respect to the inner first and leaving that all alone, and then you're going to multiply by eventually the derivative on the inside. So the easiest way to look at this is like this. We're going to pull down that 3 because we're deriving around the inner function. And then I'm going to reduce by 1. That was our normal derivative. If we had x cubed, we would have done that simply. But then we're going to say, well, I left the inner alone. Now I need to go back and derive the inner. So derive that inner. Alright, so this would become, we would have to do it piece by piece. So the derivative, I'm going to go ahead and float through this, but I'm going to backtrack. There it is. What we just did is we derived around the inner, derived around inner function, but then we went back and multiplied by the derivative of the inner. Okay, so again, what we were saying here is y would have been just equal to u cubed. It was equal to some inner function cubed. U was equal to the 3x to the 8th plus 2. So what we did first was we derived around the u, so dy du would have just simply been saying, okay, let's take this and use the power rule on it, u to the second. Alright, but then if we wanted to derive u with respect to x, this is where we would have said, alright, the derivative of 3x to the 8th plus the derivative of 2, and we would have gotten, pull out that 3, so equals 3 times the derivative of x to the 8th plus 0. Oh, sorry, I'm going to keep it derivative of 2. And now I'm actually going to start deriving. So du dx is equal to 3 times, and then the 8 was pulled down, so it's going to be 8x to the 7th, and then plus 0. That was all of our familiar rules, but now what we're just going to do is multiply these together, multiply these things together, because then what we have is dy with respect to x. And I am going to go ahead and say we know what u is, so I'm going to sub back in what my u is equal to. So we have 3 times the 3x to the 8th plus 2 times, and then this du dx, which would have been 24x to the 7th. Okay, but again, what you're doing is deriving around the inner function, leave inner alone. Okay, derive that outer function and then multiply by the derivative of the inner. Okay, another way to look at this is the f of u equals u cubed, where u is equal to, and then 3x to the 8th plus 2. Another notation for this, if we ever wanted to find the derivative of f of u, what we would have to do is f prime of u, so derive the f function with respect to the u times the derivative of u. Okay, so that's just another way of writing it. So here again is what we would do. Well, we would say the derivative of f with respect to u would have just been, use the du of u to the third. Well, that's just dropping down the 3 u to the second. Power rule right there. It's the same as if we had d dx of x cubed. We would have used it and dropped down that 3, reduced the exponent by 1. So we have 3u to the second times, and then the derivative of u with respect to x. Again, that side work over here is going to be d dx. I'm going to put the 3x to the 8th plus d dx of 2. So we're going to get 24x to the 7th plus 0, and then that's when we would tag that on to the end. Okay, don't forget to go back and put in your u, because ultimately we were saying I wanted to derive with respect to x, so we want our variables to be x. 3 times, and then 3x to the 8th, plus 2 to the 3rd, times 24x to the 7th. So I am going to lump this 3 and this 24 together. That's going to get us 72x to the 7th, and then 3x to the 8th, plus 2 to the 3rd. Anything beyond foiling to a degree of 2, you don't have to FOIL out. This would be fine the way it is. Alright, let's do another example. Let's derive this. So I want to find, I'm going to go ahead and rewrite this as f of u is equal to 3 times u to the 4th, where u is equal to 9 minus x squared. So what I've just recognized is that I want to do f prime of u times du. So derive around this outer function and then multiply that derivative of the inner back on. The easiest way of doing this then is to just take this piece by piece and say, alright, f prime of u would be the same thing as deriving this with respect to u, 3u to the 4th. And when you do that, you can pull out that 3 by the scalar multiple rule. And what we would get here is 3 times, and then 4u to the 3rd. Right, so this right here is f prime of u. And then let's go ahead and do times du with respect to x this time. So we're going to say then d dx of 9 minus d dx of x squared. And what we're going to get is 0 minus 2x to the 1st, or in other words, just negative 2x. So all in all, we're going to multiply these together. We're going to get 3 times 4, and this is where I'm going to put my x, what is my u equal to, in for that u. Well, it's right here, to the 3rd, and then times negative 2x. That came from here. This came from there. Okay, and that scalar multiple just had that 3 out in the front, so now let's simplify this. Actually, this would be 12 times the negative 2 would be negative 24x, 9 minus x squared to the 3rd. Again, this is, no. That's greater than a power of 2, so you don't have to FOIL out. You can leave it as it is. Alright, I'm going to go ahead and get you started on this one. This is f of x is equal to, and then I'm going to rewrite this, 9x to the 2nd plus 4 to the, and remember roots can be rewritten as rational exponents, so I'm going to write it like that. And again, I'm going to say, well, f of u would then just be u to the 1/3. Then u is equal to that inner function, 9x squared plus 4. Alright, so go ahead and use the same idea that we used for number 9 for this.